The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of Noah's GOES T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Daryl, let's listen in as we listen to United Launch Alliance Rob.
This look good.
Who was the flight mission commentator.
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We are now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Max Q, 48 seconds.
We have passed through Mach 1. The vehicle is now passing through max Q, maximum dynamic pressure.
They throttle back those RD-180s.
Now 55 seconds into flight. Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1,900 miles per hour. RD-180 is now throttling back up.
They backed off the throttle to reduce
Now
the
at
stress
75
of the
seconds
rocket.
into flight. Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles per hour. Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
In 10 seconds, those solid rocket motors on the side will cut off. Beautiful shot from space.
SRBs have burned out as expected, and we see a good SRB jettison.
Clear shot of those
Vehicle is now
SRBs.
executing closed-loop steering.
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time. Now 135 seconds into flight. The RD-180 has throttled down slightly. Vehicle performance continues to look good at this time. Tank pressures are stable and Atlas booster battery voltages remain in their expected ranges. Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
Now they'll jettison the payload fairing, which protects GOES T at 3 minutes and 30 seconds.
We have just over 1 minute until BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit. Standing by for payload fairing jettison. And we've seen a successful payload fairing jettison.
Good shot of those fairings.
RD-180 is throttled back up now. And the vehicle has reached a 4.6 G acceleration limit and will maintain this level through BECO.
And you're looking at animation now.
We've seen that the Centaur has begun its boost phase chill down sequence.
Booster about to cut off.
And BECO, booster engine cutoff. Standing by for stage separation and a successful stage separation event. We've seen pre-start on the RL-10. And mess one, we have ignition for the first burn. This first burn of ULA's Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
What a shot there, huh, Mick?
Yeah, that was great, Daryl, to see all that and listen to Rob Kesselman call that flight. The first stage performed very well this afternoon, and everything's looking good. Those GEMS
Activity on the reaction control system as it begins its periodic firings to maintain thermal control conditioning.
Yeah, those GEM 63s performed well, solid rocket boosters, and RD-180 performance well. What I really liked was when we saw the payload fairing come off. That was a great shot from the camera. Saw the payload fairing come off, and then most people probably noticed that little half cylindrical come off after payload fairings.
Yeah.
That was what we call the Centaur forward load reaction deck. Because the fairing, the 5-meter fairing, encompasses both Centaur
As expected.
and the GOES-T satellite, there's a load ring that's inside the fairing around Centaur to help keep that 5-meter fairing from flexing. So that's what you saw when you came off there.
I was wondering about
And the
that.
engine response remains nominal. I just
And so
received word from the Trajectory and Performance Group that booster performance was as expected for the booster phase of flight.
All right, we're going to keep an eye on this burn and listen in. But in the meantime, we'll send it back to Megan out at the host desk.
If you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw GOES-T launch from just behind us at Cape Canaveral Space Force Station. And guess what, everyone? I just found out that this was Kevin's first launch.
It was.
How was it?
It was super exciting. Almost a proud moment as an American, 20-year Air Force vet, and to be able to see this was awesome. Absolutely awesome.
Yeah, I'm so glad to be here. It was very fun to watch you react. Like you were like, you were like a kid. Like,
Like
I have
a
to see
kid.
this. Oh, wow. It was
I
great.
Absolutely.
It was great. So what's next for this mission?
Well, the wonderful thing about this, now that we've had a successful launch, we have about 12 days before it actually reaches geostationary orbit. So at that point, that's when we'll start our checkout phase. We'll be looking for the data to come down from the spacecraft to make sure everything checks out, that the images are correct, all that kind of stuff has to work its way through.
And, GOES is NOAA's latest weather satellite, as we've said. We've been launching GOES satellites together for nearly 50 years. I mean, there's been so many advancements made in between those times.
There have. And, I like to remind people that, this particular satellite in the series is really an evolutionary step, much like cell phones. Or when we talk about, hey, do you remember when we used to use landlines and rotary phones? Well, think about the leap we've taken from then to the cell phones and the capabilities that we have, much like that with our satellites.
Yeah, I know. I feel safer knowing that GOES satellites are up there. And now I'd like to bring in NASA's Leah Martin, who got to watch the launch with our agency's Deputy Administrator. Leah.
Hi, Megan. Like you said, I am here with Pam Milroy, NASA's Deputy Administrator. And what did you think of that launch? So exciting.
It was exciting, and it was, I don't know, I always just feel this electricity when a launch goes up. You're like, wow, people can do this. This is just the power and the majesty of it as you see it lifting into the heavens. It's always exciting.
And, hours and hours and months of work that go
Yes.
into it. Absolutely. So, NASA's vision is to expand knowledge for the benefit of people here on Earth. That's the heart behind everything that we do. How does this mission fit into that?
This mission is a great example of our mission in a lot of different ways. I think one of the most powerful things that we do at NASA is we partner with others to maximize the benefit of the things that we do. So this mission to launch the GOES-T satellite will enable us to have cutting-edge capabilities that are looking down on the Western Hemisphere, the western part of the United States, to ensure that the data that goes into the NOAA models around weather are optimized, they're up to date, they will affect people's lives, whether it's farmers or protecting from wildfires. But what's interesting is we're also going to take that data because we have Earth scientists who are modeling our Earth as a system and climate far out into the future. This isn't an operational weather, which is what NOAA's mission is. They do it very well. But we take this data and we also use it for the benefit of science. So it's a really synergistic partnership.
And you just mentioned climate change and monitoring the changes because that is a priority for NASA.
It is. It's one of our top priorities. We are already doing a significant amount in this area. Earth science and looking at our own Earth has always been an important part of our science mission. Interestingly, we also study other planets in the solar system, such as Mars, which we believe was once wet and had more of an atmosphere. And so the question is, how did it get the way that it did? And how do we make sure that does not happen to our planet? So it's a critical part of our mission.
Well, we're hoping that the information that we get today can feed into the future missions of tomorrow. If nothing else, we'll certainly know the weather. Pam, thank you so much for joining us today. We really appreciate it, and we hope you enjoyed the live.
Exciting day.
Megan, back to you.
Thank you, Leah and Pam. And Kevin, GoSee doesn't just forecast the weather. We've talked about this a little bit. You know, we've talked about how it monitors the atmosphere for fog, dust storms, and smoke, and especially for wildfires. But what about like smoke and ash for volcanic eruptions?
Yeah, absolutely. This past year has been kind of a revelation in our capabilities to view volcanic eruptions. In particular, probably the most spectacular example would be the Tongan. But what we also have is another example in the Caribbean where you can see not only the amount of ash that goes up, but the area that it covers. And as a result of that particular hazard becomes an aviation hazard in particular.
Yeah, you can see all the smoke there. You know, weirdly enough, 2 years ago, I was traveling in the Philippines and there was a volcanic eruption there and we had to ground hundreds of flights because of it. So really, GOES helps decide whether or not it's safe to fly.
They do. Again, NOAA's partnered with the FAA and they provide them with those volcanic ash, both forecasts and projections for where that ash could go.
All right, we're now approaching another milestone in the ascent. Daryl and Mick, back to you.
Thank you very much, Megan. And we continue to burn, continue to get good numbers as we monitor the flight of the Centaur and GOES-T.
IP vanish.
Yeah, things are looking really great on this flight, and coming up on MECO 1 of that Centaur engine as Centaur continues to perform nominally. We've heard pressures and everything look great.
PU system has gone open loop.
Here in about 10 seconds, we'll have the
Standing
cutoff.
by for the end of the burn. And we have MECO. Main engine has cut off.
There you go. That completes that first burn. And so now we go into about an 11-minute coast phase, Mick.
At this time, the GOES-T spacecraft and ULA's Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in the orbit prior to beginning the second main engine burn.
And what you're looking at is animation that is tied directly to the telemetry we are receiving from the rocket.
Yeah, the team is using all the vehicle telemetry to look at and
The
power
reaction
this
control system is operating at the 100% settling mode at this time.
power this animation that we're seeing, which is really good. And as we heard Rob Kesselman say a minute ago, this approximate 10-minute coast, we're in this park orbit around Earth right now as we coast around to get into the proper trajectory we want to be for that second burn, which will then send us on our way towards that geostationary spot we want to be. It'll be a longer burn, and then we've got, Daryl, that long 3-hour coast that we're going to wait around for.
3 hours, folks, between the points on the bottom of your milestone list, between MECO 2 and MES 3. That's 3 hours. It's short there on your screen, but it's a long one. As you're looking at the animation, we are in orbital darkness. The sun is blocked out, and so the animation is reflecting that at this time. So we can't see the Earth behind it. They give it that kind of accuracy in terms of its look. So the spacecraft is in total darkness, but when it comes out and those solar rays unfurl, it'll have some power. All right, we're going to send it back to Megan for now and while we coast, but we'll be back for that second burn.
Thank you both. Now, GOES-T will warn us about weather here on Earth, but also space weather. But what is that, and how does it impact us here on the ground? Take a look.
So the sun, looking here from the ground, seems very constant and quiet. But actually, when we look at it from space, we can see it's quite turbulent and active. Space weather is activity on the sun and in a near-Earth space that can affect our technological infrastructure and society. The sun is constantly spewing out a stream of particles called the solar wind that goes out into the solar system. And it affects us here near Earth, where we're protected by a magnetic field. The interaction between the solar wind and the magnetic field can cause space weather. Carrington event is the largest storm we've seen in recorded history when we're looking at space weather. But every solar cycle, which repeats about every 11 years, one estimate estimates that there's a 10% chance of getting a large storm like the Carrington event that could impact us here on Earth. But we see solar storms almost all the time. And these storms have an effect on our technological infrastructure. Solar storms can cause activity in Earth's atmosphere and magnetosphere that can damage electrical power grids that power our communities, interrupt radio and satellite communications, and can cause our GPS navigation to fail. NOAA is working with its international partners to ensure that we have different vantage points where we can observe space weather. Our space weather observing infrastructure from space includes the NOAA Discover satellite and the NASA ACE satellite that are stationed upstream of Earth to give us a first buoy measurement of the solar wind. It also includes the ESA-NASA SOHO satellite and the NASA Stereo satellite that image the sun and also make coronagraph measurements of the outer atmosphere of the sun, the corona, that can tell us when large explosions happen off the sun. We also observe the sun and the Earth's magnetic field from the geostationary location with NOAA's GOES. So the way we use the space weather information from satellites and from the ground is to be able to make forecasts and predictions, just like we do with hurricanes and terrestrial weather. We observe the sun and look for activity and see how it develops, and see if it's going to culminate into a large explosion that can affect us here on Earth. NOAA is working with its international partners to expand our observing capability. We're committed to observing along the Sun-Earth line. So we're going to do the imaging of the sun and the upstream buoy measurements of the solar wind along the Sun-Earth axis. The more we understand about the sun, the more we can prepare for it and become, just like we are a weather-ready nation, become a space weather-ready nation. And as we look forward to humans exploring out into the solar system and advancing our space commerce activities, space weather becomes more and more important.
GOES-T is one of many satellite programs operating right now. Leah is standing by with someone you know very well, Kevin.
Dr. Spinrad, our administrator.
Yeah, NOAA's administrator. All right, take it away, guys.
Hi, Dr. Spinrad. Thank you so much for joining us today for the GOES-T launch. We really appreciate it. So this launch is actually not the only NASA NOAA launch that we have a collaborative effort with this year. We have another one coming up as well.
Yeah, that's right. Thanks for having me. And in fact, this next launch will be a polar orbiter, which is fundamentally different from what we launched here today. So this is, we call it a geostationary satellite. As the name implies, it's Earth synchronous. It actually follows around and looks at one spot on the Earth, if you will. And then the JPSS launch is, we call it a sun synchronous. So it actually stays at a certain sun illumination and does orbits around the pole many times to give us a different look at the Earth as it's spinning on its axis. And you take the JPSS satellite data and the geostationary data together, and it's like taking pictures at multiple angles to get a much better idea of what's happening on the planet.
So that's information that we can use independently, but we can also use them together just to get a better picture of what's happening.
Absolutely. Think of it in terms of being able to forecast weather, say, 2 days ahead versus a week ahead. And if you've got multiple views of the planet, you can start getting a much better handle on when hurricanes are forming, where they're forming, how intense they are, or things like atmospheric rivers forming way out in the middle of the Pacific. When will it arrive in the Pacific Northwest? So having these these multiple ways of looking at the Earth gives us a lot more and a lot better information for these critical forecasts to save lives, protect property, and basically protect our American public from these natural phenomena.
Now, and the system that is currently on orbit is set, I believe, to go through the 2030s. What comes after this?
So we've called this series the GOES-R, the Geostationary Operational Environmental Satellite R series. There are 4 of them. We've launched the 3 here today. And after this series, we're looking at what we call GeoXO, extended observation. So what does the next generation of geostationary satellites look like? What's the newest technology we can put on there? Are there